Hi, my name is Kate Giamalvo, and this is my project on the economic and sustainability evaluations of carbon dioxide capture and transformation technologies. The background of my project is that carbon dioxide is contributing a lot to global warming, which is obviously something that scientists all over the world are really concerned about. So, one thing that people have been doing is capturing that carbon dioxide from the atmosphere from other sources in the environment and then storing it long term, whether that's in the ground, deep in the ocean, or in some other form. However, this process can often be really costly, which is a barrier to people actually taking the time and setting this up and doing this. So recently there have been a lot of technologies developed which are designed to create a value added product out of the carbon, which means that the process of capturing it is then the cost of that is offset by selling the product at the end, which has a higher value than the cost of capturing the carbon in the first place. There have been some really interesting developments in this. Most recently, some people are making diamonds out of it and turning it into jewelry, all kinds of really cool things. So my project was to sort of get some background information and evaluate where the different technologies in this field stand in terms of the energy demand that each of the processes needs, as well as the amount of profit that you could make from different types of scenarios, different types of products, and different types of capture methods. So as you can see in this flowchart on the right, I considered three common carbon dioxide sources, which were air, ocean, and point sources, which is sort of a flume um, coming out of a factory or something like that, anywhere that there's a high concentration of carbon emissions at a single point source. So then for each of those sources, I considered the most common capture technologies. So for air, that's direct air capture. For point sources, that's amine scrubbing. And then for the ocean, there are a lot of emerging methods, but nothing that's really very standard or well established yet. So I chose two of the more well established ones, or the ones that had the most research on them, to consider for this project. Then I tried to consider a variation of a bunch of different types of products to sort of cover the range of different types of products that you could make. So obviously you could make pure CO2 and sell it just the way it is, and make a profit that way. You could also transform that CO2 into calcium carbonate, which is a solid that's often used in construction and agriculture, but it's also a dietary supplement. Or you could create methanol, which is a type of fuel, and there are a lot of other type of fuels that you can make, but I chose just this one as an example for my project. And then you could even use that methanol to create other things, such as aromatics or different kinds of thermoplastics. So I considered all of these products as just a subset of the types of products that can be made with carbon. I looked into the different amounts of energy that are required for each of these processes. So first I considered the amount of energy that would be required at a minimum to capture the carbon dioxide from different point sources or different air sources and things like that, and then to turn that into carbon that is separated from the rest of the source and concentrated or pressurized to a common storage pressure of 12 atmospheres. So you can see these equations on the left are the thermodynamic separation minimum energy and the minimum thermodynamic pressurization energy. So in the first figure, you can see how those thermodynamic minimums compare to the actual energy that's required for each of the capture technologies. You can see that EDI and electrolysis is a very, very new technology, which has a lot more energy required because it hasn't been optimized quite yet. And the lowest capture technology is amine scrubbing, which is makes a lot of sense because the amine scrubbing uses carbon that comes from point sources, which are much, much more carbon concentrated. 65% by volume of CO2 is sort of the max there, as opposed to air, which is 0.04%. So then on the right, you can see a plot of the total net energy required for each product. So that's a summation of all of the processes to get all the way to that product at the end. So as you can see, CO2 has the lowest because it has the least processes required. And then that's a net energy. So from that, I subtracted the energy required to make to make that product in a traditional method or for fuel. So for methanol, I subtracted the energy content of the methanol, so the energy that's essentially created by the process of making methanol using carbon capture. Then down on the left here, you can see a plot of the cost considerations. So in the y-axis, you have the profit in dollars per ton of carbon. And then on the x-axis, you have the energy input in gigajoules per ton of carbon, with the size of the circles corresponding to the size of the market. All three of these variables are really important when deciding which of these products you would like to create. For example, benzene is way less profit associated with it, but it also has a way larger market size, which may make it easier to produce that and to sell it in large volumes. So there are really a lot of considerations that would go into choosing which of these paths to take, and so I wanted to provide an easy visual way to compare those. So then for my conclusions, the aim of this project was to create a point of comparison for new and emerging technologies, and I think that I've done a good job of sort of creating a point of comparison in terms of where the industry stands now. However, the technologies that I chose are nowhere near a complete image of all the technologies that are available, or even all of the common, well-researched, well-developed technologies that are available. There are way more products that are able to be developed, so like diamond, methane, all of these different kinds of things that are also value-added products. So the next step of this project will be for me to expand the number of products that I've included to include some more products to sort of get a more broad image of where the field is and how new technologies can be developed and where those new technologies need to get to in terms of profit and energy considerations in order to be competitive in the market. Another research area that I think should be considered in the future, but which I might not necessarily get to, is that other impacts of these technologies should also be considered. So, for example, eutrophication, global warming index, the amount of water they use, the amount of other materials that they use. These kinds of things are also sort of important in a true economic evaluation of these technologies. Right now, it's sort of hard to evaluate that because a lot of these technologies are very new and there's not a lot of information available about this kind of thing. But I really think that that's sort of where this research needs to go and where the people developing these technologies need to look as they move towards a more complete picture of how we can capture carbon and create value-added products out of them. So I originally got involved in this project because I spoke to my research mentor. I was already working in her lab, and I talked to her about the possibility of doing an honors capstone with her, and she actually had this CO2 capture project coming up that was really new, and they needed some people on it, and she asked me if I would be interested in doing sort of a background of the existing technologies to give her lab a point of reference for how they should improve or where they should look to improve upon what's already out there. So it was really cool to be able to sort of start something from scratch, and sort of let my work influence where the rest of the team is going with this, moving forward. One challenge that I didn't really anticipate was how difficult it would be to get a complete image of how much these sort of chemicals sell for. It's actually was really difficult to find this information. I had to go through the library and sort of get them to get me access to a database that we didn't already have access to, which was somewhat difficult to figure out how to do, but now that I know how to do it, it's a really awesome skill that I think is really cool to have. And going forward, I'm actually continuing with this project over the summer, so I'm excited to see how it wraps up and to be able to complete it by getting a more complete picture of the different products that are possible from carbon. And then beyond that, after I complete that, the rest of the team will be using that to sort of compare their developing technology with the rest of the technology that's already out there, and sort of figure out where they can go next. Thanks for listening.